any point, you need to stop and ask me questions. Okay, so you guys, yesterday we moved like the power rule, the product rule, and the quotient rule, we moved forward. So they gave us a multiplication problem, we wrote it as addition. They gave us a division problem, we wrote it as subtraction. Today what we're going to do is we're going to kind of work backwards. They're going to give us a subtraction problem, we're going to write it as division. They're going to give us an addition problem, we're going to write it as multiplication. They're going to give us the number in front of log. We're going to write it as an exponent. So we're doing everything backwards where yesterday we went forwards. Okay, so do you notice that there's a 3 in front of log? Okay, yesterday we would have taken and put in a 3 in front of it, but I don't want to do that today because I'm trying to solve it. So yesterday we were just evaluating it. Today we're trying to solve it. So we're going to apply the power rule backwards. So I'm going to take it log base 10 of x to the third power. So in the last section, we learned that if the bases were the same, right? If the bases were the same, we could drop them and solve the equation 64 equals x to the third. Tomorrow's lesson will actually show you how we divide and why that works. Okay, now, how do you get rid of something that's cubed? We're going to take the cube root of 64. And we're going to take the cube root of x to the third. So the cube root of 64 is 4. The cube root of x to the third is x, and that's our answer. And you guys, the log of 4, that's perfect. It just can't be negative, so that's your answer. So on tonight's homework, this problem is like 11 and 12. So if you go to do 11 and 12, you have an example that looks just like it. Okay?
Is tonight's homework going to be due tomorrow?
No, it's due on Monday. Okay, so for problems 13 through number 16, we're going to do this problem right here. And it's log base 6 of x plus log base 6 of 9 equals log base 6 of 54. So we learned yesterday, if we had a multiplication problem, we could write it as an addition problem, and that's what we did. But today we have a variable, and so we're going to do the inverse. So the inverse says if we have an addition problem with logs in it, we can write it as a multiplication. So it would be log base 6 of 9x equals log base 6 of 54. The bases are the same. So we can set it 9x equals 54. If we divide each side by 9, x equals, and that's your answer. What questions do you have right now? Any questions? This should be like problem number 17. I think there's a couple other problems like this. Okay. So there's a couple things about this problem that I see. One, okay, so I see it. What do you guys see? What? They're the same base, so that's good. What else do you notice? There's a 4 in front of the log. That's good. What else? One more thing that you should notice. It's an addition problem. So addition can be rewritten as multiplication. what happens with this 4? So you guys, in your notes, I want you to write everything out, because that way, when you're going to do your homework, you can actually see how I did everything. So we're going to rewrite it as log base 2 x to the 4th plus log base 2 of 5 equals log base 2 of 405. And you guys said, hey, it's an addition problem, so I can rewrite that as a multiplication. So you guys remember order for multiplication doesn't matter, and you're just going to put the coefficient, you're going to put the 5 first because that's the number, and then you put the variable. Log base 2 of 405. You guys also noticed that the logs, the bases were the same. So I have 5x to the 4th equals 405, sorry. And now, what do? We're going to divide both sides by 5. We have x to the 4th equals 81. Oops. Okay. And then how do you get rid of a 4th root? We're going to take the 4th root of both sides. The 4th root of x to the 4th is x, and the 4th root of 81 is? And there's your answer. What questions do you have?